हाय फ्रेंड्स, आज आपण लाप्लास ट्रान्सफॉर्मची सेकंड शिफ्टिंग प्रॉपर्टी आणि त्याच्यावरती एक्झाम्पल्स बघणार आहोत. लाप्लास ट्रान्सफॉर्म ऑफ f of t minus a into u a into t is equal to e to the power minus s into phi s. This is formula for shifting property second. What is u? Where u is unit function, uat is equal to 0 and 1. There are two values. This value is provided for t less than a and this value is for t greater than a. Then we have to find out Laplace transform of this. So you are asked to show that this equals to e raised to minus a into phi s by using shifting property. So here proof. ही जी प्रॉपर्टी आहे ती तुम्हाला परीक्षेला 5 मार्कांसाठी विचारली जाऊ शकते. याला म्हणतात सेकंड शिफ्टिंग प्रॉपर्टी ऑफ लाप्लास ट्रान्सफॉर्म. सो वी स्टार्ट विथ दिस. वी हैव f into bracket t minus a into u unit function of t is equal to curly bracket. Here 0 and here you have t minus a. This is for t less than a and this is for t greater than a. Now why 0? Because u is 0. Therefore this multiplied by u, it comes 0. It is 1. If it is multiplied by 1, same thing you are getting. Conditions are same. This is what is product of unit function and given function. Now question is, what is the Laplace transform of this? So here we start with LHS, left hand side. Laplace of f of t minus a into u a t, which can be written as 0 to infinity. You can remember this e raised to minus s t compulsory and then it is multiplied by f of t minus a into u a t into dt. And now we evaluate this integral. See, 1, 2, 3, there are 3 functions. But after all, f of t minus into u of t is nothing but 0 and t minus a. And therefore, this integral can be divided into 2 parts. First part is 0 to a and second part is a to infinity. So in 0 to a, this part 0 to a, this f of t minus into ua, this is t less than a, it is 0, plus then integration starts with a to infinity and then e raised to minus s to compulsory. Now you can write down this value for t greater than a. This is t starts from a, that means t is greater than a. Corresponding value is f of t minus a. And therefore we write here dt. आता याच्यामध्ये गंमत बघा की आपल्याला इंटिग्रल इव्हॅल्युएट करायचे. सो टू कन्वर्ट दिस इंटिग्रल इनटू स्टँडर्ड फॉर्म, हियर वी राइट 0 डायरेक्टली प्लस हियर a to infinity. Here we have to substitute the value of t minus a to be capital T, for example. For sake of simplicity, we put t minus a is equal to t. So what is dt? Derivative of t is dt, derivative of a is 0 and derivative of capital T is d capital T. What about limits? If you substitute something, you have to find out new limits. What are the old limits? Old limits are a and infinity. But note that these are limits with respect to small t and therefore t runs from a to infinity. What about capital T? If your small t is a, then what is value of capital T? How to find out? there is formula. Value of capital T is supposed to be T minus A. If you put small t is equal to A minus A will be 0, and therefore, second thing, upper limit is infinity. Therefore, this directly comes infinity because infinity minus A is infinity. Now we are ready for this integral, which is equal to integration from 0 to infinity. We don't write A to infinity because these are old limits, and now we apply new limits. Here e to the power minus st is going to change. Small t is nothing but A plus capital T. Okay, small t is equal to A plus capital T. This full value is supposed to be small f, and here also directly small dt becomes capital dt directly. Okay, so how to simplify this? This picture is very nice. You can imagine in this way: e to the power minus as, then minus st, ft, dt. And now thing is, this we can take common because it is constant. Because it is constant. But this is not constant because your integration is with respect to capital T. So what we get inside the bracket? E, one more. This is we have taken common, but still E is there, minus st, and then f of t dt. This is what is the expression. So this expression tells you this answer comes. This is e raised to minus s. This whole integral is nothing but Laplace integral, and therefore it is supposed to be phi into bracket s full stop. So this is what is the proof of this property. तर ही प्रॉपर्टी तुम्हाला परीक्षेला 5 मार्कांसाठी विचारली जाऊ शकते. या प्रॉपर्टीमध्ये बेसिक काय करायचं, डेफिनेशन अप्लाय करायची लाप्लास ट्रान्सफॉर्मची, and this is what is the okay. Now we will see problems depending upon this property in next video. Thank you.